Hi, I'm Ram Kishore. Today, I'll explain the concept of reversing a linked list. I assume we are all familiar with the basics of a linked list, the operations that can be done on a linked list, namely insertion and deletion. Today, I'll explain reversing a linked list with the help of an integer linked list. Here is a structure of a node in an integer linked list. Each node has a data variable of type integer and a next, which is a pointer to an object of type node, which is a structure. So this is an example of a self-referential structure. Here I have an example of an integer linked list. The head pointer points to the first node in the linked list, first node in turn to the second, second to the third, and third in turn to the row. After reversing a linked list, the head pointer would be pointing to the last node of the linked list, the last would be pointing to the second last in turn to the first in turn to the null. So there are three things to be done while reversing a linked list. First, the first node must point to null. Second, for every node that we are reversing, we have to store the address of the next node that it was pointing to originally. Third, the head pointer must point to the last node. So now after I'll explain this reversing of a linked list by writing some code in C. To this function reverse, I pass from the main function address of the pointer that was pointing the head of the linked list, that is the first node of the linked list. This is because if I don't pass the address of the pointer, then any changes made to the linked list in the reverse function won't be reflected in the main function. Thus, I pass the address and it is called as call by reference. If we don't pass the address, just pass the value, it is called as call by value. Here, I have three temporary pointers, current, previous and next. Current would hold the value of the head pointer, previous would be null, and I have a next which I will not initialize now. I'll explain what values these three variables take subsequently. I have a while loop here where the current variable would go from one node to the next in the linked list until it gets to null. So as per a second condition, we had said that whenever I try to reverse a node in the linked list by assigning the current node to the previous node, I need to store the next node that it was pointing to originally in some variable. That is what I am doing here. If I don't store this, then after reversing, the address of the next node that it was pointing to would be lost. So this is a step where we assign the next of the current node to point to the previous node. So while doing this, for the first node alone, it is different, where first node would be pointing to null. That is why I have initialized the previous to be null, so that it satisfies the constraint for the first node also. These two statements in the while loop are used to traverse the previous and the current node. So both of them go from one node to the next, but the previous will be one node behind the current node and the next will be one node ahead of the current node. So while the current node becomes null, it would come out of the loop, and at this stage, next would also contain the value of null. However, previous would be address of the last node in the linked list. So as per the third condition, we need to make sure that the head node points to the last node of the linked list. So this line of code handles that. So this is the basic code for reversing a linked list. Thank you.